In this presentation, we introduce a generalized form of Merkle tree called hyperhash graph, by relaxing the criteria of the child nodes of an inner node or inode to include arbitrary strings besides hashes. Such a well-defined and easy-to-understand generalization has many interesting consequences. Merkle trees are being used in many cryptographic applications, ranging from BitTorrent file sharing to cryptocurrencies such as Bitcoin. Hyperhash graph is a crucial fundamental component of Omni Web, an initiative to build a truly decentralized web, owned and operated by individual users and free software programmers, by creating a platform where users and programmers may collaborate and build the decentralized system infrastructure based on digital assets, which are in turn monetized and organized using Omni Web's own unique and omnipotent omnihash. Firstly, hyperhash graph, HHG, can now be used to model contracts between two or more parties, shown here as Omni contract, with a simple contract that says, Brian will pay Adam $50 for a trip in Adam's car from Hong Kong Airport to Hotel Continental, on 1st of August 2024. Next, the same Omni contract is visualized as hyperhash graph. It looks similar to a Merkle tree, but it is not uniform, and the node on the bottom left contains contract text instead of a hash string. Secondly, as the child nodes can be any arbitrary string, a child node may consist of a hash or identifier, including URI or Uniform Resource Identifier, which points to one of its ancestors, thus effectively making the network a graph, with no unique root node, instead of a tree, which always has one unique root node. Hence the name hyperhash graph. Note the red and purple arrows in the diagram, which makes the network a graph, but not a tree. If domain name system DNS and uniform resource identifier URI are the fundamental building blocks of the centralized web that we use today, then Merkle tree and hyperhash graph HHG will be the equivalent for constructing a truly decentralized web. Since Bitcoin release in 2009, the world has witnessed how a clever algorithm that is Merkle tree grow to power over 18 trillion US dollars per day on a centralized exchange SEX. However, decentralized algorithms have not been able to liberate, borrowing a Marxist term here, the last mile of user daily transactions, on the web browser or mobile devices. Omni Web hyperhash graph HHG is here to achieve that. In a previous video, we mentioned Instagram owned by Meta for example, who charges advertisers for revenues, but does not share any profits with individual users or free software programmers, whose data and source code hugely benefit the company. Using OmniHash and hyperhash graph, revenues from OmniStargram, a clone of Instagram, which include advertising or other sources, can be shared with individual users and free software programmers themselves. In this presentation, we shall demonstrate how hyperhash graph can be used to make payments denominated in gold or silver bullion, between two parties physically located in separate continents. More specifically, we shall demonstrate how Donald in London, the advertiser in OmniStargram example, shall make payments to Adam in Hong Kong, who set up an Omni Web Invisible Internet Project I2P server. This is to illustrate this solution shall overcome the tyranny of US dollar, and its implementations depend only on large number of individual users and programmers making the right choice, that is to choose a self-sovereign mobile application, instead of staying ignorant and refusing to accept any instructions not coming from the white masters in the White House and Wall Street. This is like 1,000 or tens of thousands of people lighting up candles in a dark cage. Let there be light. But this time it is individual men who shall take the action. Fiat Lux. Now let us examine an example of a digital contract between Adam and Donald, where Donald agrees to pay Adam the value of 1 troy ounce of 0.999 silver, or about $30, for providing 10,000 views of advertisement. This contract is generated on OmniStar contract page at https://omnixdr.github.io/omnicontract. This innocent-sounding contract may potentially violate relevant laws in the United States of white America, as gold and silver had been outlawed by a few white men in the White House as means of payment. We shall examine this issue of white supremacist Americanism later, after we go through the fundamentals concerning hyperhash graph and OmniStar contract. Now let us compare OmniStar contract to a conventional paper contract, where the signatories usually put down their signatures on a piece of paper, together with the contract texts. In OmniStar contract, the variables PBKA hash and PBKB hash are the hashes of public key for party A and party B respectively. Hash of public key is explained in the previous YouTube video, whose link is given in the description section of this video. It is the equivalent of physically written signature, although the underlying mathematics will be skipped for now and left for future tutorials. Let us take a look at how conventional international money transfer such as Western Union works, to illustrate the steps and complexity of a service that we take for granted, and how hyperhash graph may simplify it so that it can be operated and managed by just a few individual agents. A client of Western Union usually walks into a counter, makes a request to transfer money by filling up a form. The form is in fact a contract between the client and Western Union Company. There are several hundred words which spell out the detailed terms and conditions. Behind the scenes, Western Union would sign multiple contracts with its partners, and its partners would in turn sign various contracts with their subcontractors. Such information is of course not publicly available. But we could model it with a scenario using hyperhash graph and OmniStar contract. Let us start by describing the bigger picture of the decentralized payment system based on gold and silver bullion. Within OmniStar web platforms, every physical piece of gold or silver bullion owned by a user, in the form of bar or coin, may generate a hash number or hash code as its identifier. Let us call it hash bullion for convenience and abbreviate it as HXBC, where C implies coin, as per conventions in cryptocurrencies. But of course, anyone seasoned in financial business knows what HXBC resembles. The ownership of the hash code representing a particular piece of gold or silver coin can be transferred from user A to user B, using algorithms based on hyperhash graph, thus making hash bullion a practical and effective means of payment. Hash bullion is one of tri-species payments which include national fiat currency and cryptocurrencies. As shown on the screen, each of Donald, Cynthia and Brenda may choose one or more of tri-species payments for the payee. OmniStar hash bullion works by first having human payment agents located at various continents, countries, cities and down to streets, much like our favorite 7-Eleven or McDonald's. When Donald in London wishes to make a payment to Adam in Hong Kong using OmniStar hash bullion, Donald appoints Cynthia as the agent in London and Adam appoints Brenda as the agent in Hong Kong. We use the initials ABCD for convenience. To qualify as hash bullion agents, Brenda and Cynthia must demonstrate to possess twice the amount of gold bullion requested by clients for payments. For example, Brenda must possess 2 troy ounces of gold and be audited in order to qualify to make payment at a maximum of 1 troy ounce of gold per transaction. Donald will make payment in one of tri-species money to Cynthia. Cynthia will then transfer payment in one of tri-species money to Brenda. Finally, Brenda will do the same to complete the transaction. Adam will physically pick up 1 troy ounce of silver coins from Brenda if he chooses to, or chooses to receive the money in fiat or cryptocurrency, or saves the payment hash code for future transactions. This description of the steps in OmniStar tri-species payment sounds ordinary and easy to understand. However, under the hood are many sophisticated considerations and simplifications to make it versatile, secure and yet easy to use for Tom, Dick, and Harry. To illustrate the underlying mechanisms of hyperhash graph, let us expand Donald's payment arrows so that each arrow is expanded to a pair of boxes, representing the payor and pay accounts for each type of fiat, cryptocurrency and hash bullion. The most fundamental objects in graph theory are edges and vertices, or arrows and nodes. We draw nodes as boxes as we may label it with text conveniently. The arrows and boxes representing Donald and Cynthia show that Donald has options to pay Cynthia in national fiat currency, cryptocurrency or hash bullion. Each of the payor or pay boxes corresponds to a functional component, which include bank accounts in real life, cryptocurrency wallet or hash bullion account, which Donald and Cynthia own and use. Let us now put the hyperhash graph representing Donald and Adam's contract side by side with the graph showing the payment options above. The contract was created before the payments are made, thus representing two events at different times. We may construct a super hyperhash graph to include more operations and more details, but that would be too complicated for viewers to digest at this stage. What we aim to illustrate here are the utility of hyperhash graph and how it can be used to analyze and facilitate complex transactions involving multiple parties, implemented on decentralized infrastructures, where individual users and programmers may own a piece and operate them, as the underlying algorithms have greatly simplified payment transactions used to be performed by international financial institutions such as banks and Western Union. We begin this presentation with a review of MerkleTree and proposed hyperhash graph as a generalization of MerkleTree, where the inner nodes or inodes may contain arbitrary strings instead of hash strings, and they may contain hashes or identifiers which points other nodes within the graph. We then review a scenario of OmniStargram, a clone of Instagram, where Donald the advertiser living in London would pay Adam in Hong Kong for providing a service to display Donald's advertisements. Finally, we demonstrate how hyperhash tree may be applied to model and facilitate contracts and transactions at various stages, from signing a contract to execution and payment. What we have described about hyperhash tree merely covers perhaps around 10% of its full functionalities. In a previous video about Hilbert Hotel with an infinite number of rooms, we demonstrated OmniStar Web Trimedia business model, which stands for training, infrastructure, metaprogramming, and digital assets. As hyperhash tree is such a breakthrough concept on par with MerkleTree, we shall describe more of its functionalities based on OmniStar Web Trimedia model in future tutorials. More specifically, we shall begin with a hardcore tutorial on how to generate RSA public and private key pair on Android devices using Bouncy Castle cryptography library and integrate these with JavaScript web applications, as Android somehow disabled many critical functionalities in its cryptographic library, including obtaining the string value of private keys. As a preview of the upcoming tutorial, here is the Android Kotlin app simple storage that we fork and modify. We modify main_activity.kt to save private key string to a file via the Create File button. The first screen shows Bouncy Castle libraries for import into the app. The second screen shows write test file function at line 886 where we make the modifications. In the third screen line 909 shows the Kotlin code to generate the private key. Next line 927 shows the code to write the private key as pembase64 string to a file. Here is a quick demo of the modified simple storage app in action. First, tap on the Create File button. The app will show the default file output directory. Just tap on Save button to accept the default file name. Open the output file using File Explorer and File Editor. As a rule, the private key file should not be shown to anyone else. We do this for demo purpose only. We shall also demonstrate how FOSScript metaprogramming script, derived from fourth programming language, may help simplify and unify programming languages from Java to JavaScript and PHP etc., and make it easy for junior programmers with less than 6 months of experience to start coding in such complex and versatile environments. In the long term, say by 2030, Omni Web merely aims to achieve 0.1% of top 5 tech companies' revenues, which include Microsoft, Meta, Amazon, Google, and Apple, coincidentally abbreviated as MAGA. They collectively made over $1.6 trillion in 2023. This means even at 0.1%, individual users and free software programmers participating in Omni Web could be making $1.6 billion annually by 2030. That would be the significance of hyperhash graph, a cryptographic breakthrough on par with MerkleTree. It is achievable as Omni Web trimedia model possesses all the crucial elements to build a truly decentralized web, namely training, infrastructure, metaprogramming, and digital assets. What is needed now is hope, and the efforts to recruit more individual users and programmers to join us, for the journey of 1,000 miles begins with a single step.